Hello everyone, standard 10, subject maths, chapter number 3, pair of linear equation in two variable, part 2. In previous video, we have learned about the solution of linear equation in one variable and as well as in two variable. Okay, so we just move towards to the a pair of linear equation in two variable. We know that how to write in its general form, that is a1x plus b1y plus c equals to 0 and a2x plus b2y plus c1 and c2 equals to 0, where a1 and b1 is not equals to 0, a2 and b2 is not equals to 0. That is the only condition we have seen that. Now we were talking about a pair of linear equation in two variable. Okay, so you have already studied in standard 9 two lines on a plane. Okay, two lines on a plane. So you have studied that either it can be intersect each other, parallel to each other, or coincident each other. Okay, so now we just talk about its solution. Okay, what are the solution of these two equations? Okay, if in your questions a two pair of linear equation given, okay, how you can find graphically its solution? Okay, the first thing, when you observe that these two lines are not intersecting, these two, if I say, see, when you draw a graph of lines, so you have to mention that this one is this line. Okay, this line is of some equation a1x plus b1y plus c1 equals to 0, and this one is the equation a2x plus b2y plus c2 that equals to 0. That can be anything. Okay, I am just saying in general form. Okay. So what are the solution of these two pair of linear equations, or say pair of lines equation? Okay, so when you draw a graph, okay, you found that these two lines are intersect. It means they intersect at some point. Okay, let me mark with this one over here. It means something should be common in this line so that value is satisfied both the equation. Okay, see, here we talk about a pair of linear equations. Okay, when you find a solution of that two equation, it means we found something common. Okay, we want to find something common in between that, so that value should satisfy both the equation. Okay, so see, we know that each and every point of a straight line are the solution of that equation only. Okay, here we talk about two equations. It means when this line intersects something we found over here, that is one common point. It means this common point is satisfied by both the equation. It means this common point value of x and y satisfied by both the equation. Okay, so here only one common point. It means how many solutions are there for intersecting lines? Only one solution. So you can write over here intersecting let's just write the intersecting line has one solution. Intersecting line has one solution. Okay, how many solutions? Only one solution. Okay. Now, look at the second one. The second one says a parallel. It means they have their own solutions. They have their own solutions. Okay. So this line has their own solution. This one line has own solution. What are the common things over here? Nothing is common. Only they are parallel. We are talking about the solution. When you extend this both the pen, it will never intersect. It will never intersect each other. It means they have no solution. They have no solution. So you can write over here that parallel line have no solution. Parallel line have no solution. Now, the third one, coincident line. See, coincident line, it means they both are lying on each other. It means whatever the value of this white line is satisfied by this pink line. Okay, that's why they are just coincident on each other. Okay, it means how many solutions of this both linear equation? There are infinite solutions. Why I am saying infinite? Because see, for what is the solution of this line? Each and every point of this line are the solution of this line only. Each and every point of this line is solution of this line only. It means how many points are on a line? Infinite. So there are infinitely many points on a line. So all that infinite points satisfied by both the equation. So in coincident line, how many solutions? There are infinite solutions. Okay. Coincident line has infinite solution. How many solutions? They have infinite solutions. Now, we move towards to some examples. Okay, so now understood that intersecting one solution, parallel, no solution, coincident line has infinite solution. Okay. Now, let's move towards to some. So, the question says, Akhila went to a fair in her village. She wanted to enjoy ride on a giant wheel and play hoopla. Okay. The number of times that she played hoopla is half of the number of rides she had on giant wheel. Okay. If each ride cost 3 rupees and a game of hoopla cost 4 rupees, how would you find out a number of rides she had and how many times she played hoopla? Okay, provided she spent 20 rupees. Okay, that is the question. Okay, so these questions were given in your page number 38 in the starting. Okay, over here. So question is saying example 1. This is the example 1 from your textbook only. Okay, page number 41. Okay. Now the solution. We want to find a pair of equations. Okay, pair of equations. So in this chapter, in your exam, so many word problems were asked in your exam. Okay, so you need to be very careful while finding equations. Okay, so many word problems were asked in your exam. So you need to prepare for word examples only. Okay, so let if we say how many times she play, let she take right x time. Okay, she played Hopla y time. Okay, now the question says the number of times she played Hopla is half number of ride she had on a giant wheel. Okay, it's a half of ride. So my y is equals to 1 by 2x. Okay, she played Hopla just half of the ride she take on giant wheel. This way we can represent. Okay, now each ride cost is 3 rupees and 4 rupees, and total she spent is 20 rupees. So you can write over here that 3x plus 4y equals to 20 rupees. Okay. Now look at over here. See. Now solve this equation. Now look at over here. There are two questions given. That first you have to find its algebraic expression. Okay. So this way we can represent in an algebraic form. Okay, algebraic form, it means certain variables are there, constant are there. So this is nothing but a representation in algebraic form. Now you have to represent this equation in a graphically also. So graphically, look at over here. So this one is my first equation. Okay, then so now represent the graphically. So 4y equals to 1/2 by x. We have to find different values of x and y to represent this equation in a graph form. So if I take x equals to 0, I am getting y by 0. Okay. If I am taking x equals to 0, y I am getting. If I take x equals to 2, y I am getting 1. Okay. So try to take some values so that you will get your answer in integer format. Okay, not in a ratio form. So it will be easy to represent all those points. So if I take my x equals to 4, x equals to 4, so I am getting my y equals to 2. Then these 3 points are enough. Now 3x plus 4y equals to 20. Okay, so minus 20 equals to 0. Now x and y. If you take x if I take, okay, the next thing is if I'm taking y equals to 0, so what I'm getting over here, 20 by 3, 20 by 3. Okay, if I'm taking x equals to say 4, x equals to 4, so 12 minus 28, so I'm left with 2. Okay, now we have to draw a graph. Okay, so this one is my x dash, x, y dash. Okay, so here is 1, 2, 3. So let's 1, 2, 3. Somewhere over here. So 1, 2, 3, 4. All are minus. Minus 1, minus 2, minus 3, minus 4. 1, 2, 3, and 4. Now, put all these values on the graph. For first, we just draw this. My first line, x equals to 0, y equals to 0. Over here, 0, 0. Okay. Now, okay. So this one is 0, 0 point. Now, the second one is x equals to 2 and y equals to 1, somewhere over here. X equals to 4, y equals to 2, somewhere over here. Okay. Now, just draw a line. Okay, now look at over here. This line, what is the equation of this line? This nothing but y equals to 1/2 x. This line represent, you have to must indicate that this line represent this equation. Okay. Now the second one is x equals to 0 and y equals to 5. Somewhere over here. Now y equals to 0 and x equals to 20 by 3. Then y equals to 0 and x equals to 20 by 3. Okay, so 20 by 3, it's somewhere like 6.666. So 6.666, it might be somewhere just out of the line. Okay, out of the line. So you just, when you draw a graph, just be careful. Okay, so it might be somewhere on the x line 6.555. Now the third one is x equals to 4 and y equals to 2. It means somewhere over here, like this one point only. Okay, so this one is just my, okay, over here. So this one is also lies over here. Okay, now just draw by both the equation. Okay, because look at over here. This one is the intersecting one. It means we have already learned that intersecting lines has how many solutions? They have two solutions. So from this you can say that the solution of this graph is solutions are x equals to 4 and y equals to 2. This both values satisfied my equation. Okay, now let's move towards one more questions. Take questions from your exercise 3.1. The question said, Aftab tells his daughter, 7 years ago I was 7 times as old as you were then. Okay. Also, 3 years from now, I shall be 3 times as old as you will be. Okay. So, represent this situation algebraically and graphically. Algebraically, it means we have to write this word puzzle in an equation form. So, question 1, solution. Okay. Let after present age equals to x year and his daughter present age equals to y year. Okay. So he told to his daughter that I was 7 times as old, 7 years ago. So 7 years ago. It means from present age to 7 years ago. It means we have to subtract 7 years from this both. Okay. So 7 years ago. So x minus 7 and y minus 7. Okay, 7 years ago. X minus 7, y minus 7. Okay. He tells to his daughter that I was 7 times old as you were there. Okay. So his father is 7 times older than his daughter. It means, look at over here, x minus minus 49. So 7 minus 49, so that is 42. So x minus 75 minus 42. So equation forms x minus 7y plus 42 equals to 0. So I found one equation. Now what he tells that after 3 years, after 3 years, it means from the present age to will be 3 years. So we have to write like this one, x plus 3, okay, equals to form some y plus 3h, okay. So he will be 3 times of his daughter. It means we have to multiply with the 3 on his daughter age. So x plus 3y plus 9. Okay. So x minus 3y, 9 minus 3. So x minus 3y. I'm getting over here, that is 6 minus 6 equals to 0. Minus 6 equals to 0. Okay. Now just therefore algebraic representation. So therefore algebraic representation, I'm writing just a over here. So you have to write algebraic expressions are x minus 7y plus 42 equals to 0. Okay. And the second thing is x minus 3y minus 6 equals to 0. This is the algebraic representation. Now you have to do your homework. Draw a graph.